This is R.D. Sharma solution, class 12, chapter 15, mean value theorems. Exercise is 15.1. Verify Rolle's theorem for the following function on the indicated interval fx equals to x square minus 4x plus 3 on 1 to 3. Now let us recall the Rolle theorem. First thing is the function should be continuous. If it is continuous, then we'll check for the differentiability. When differentiability is ascertained, then we go for fa equal to fb, that the value of the function at 1 and value of the function at 3 should be equal in this case. And the final one is the differentiation, the value at which the differentiation is 0, that is the C point between 1 and 3. That is the Rolle theorem. So we have the function fx is equal to x square minus 4x plus 3, and we know that this is a polynomial function. Polynomial function is continuous also, differentiable also. So finally, the third thing we are going to implement, that is 1 and 3. These are the endpoints of the domain which are given in this question. So we will try to find out fa and fb. As I just indicated, a is 1 and b is 3. So 1 and 3 we are going to take. And 1 for the value of, when we put 1 in this function, the value that we'll get when we put 3 in this function is by 1 square minus 4 into 1 plus 3. The first value will be like this, and the second value will be 3 square minus 4 into 3 plus 3. So what do you get? 1 minus 4 plus 3, 0. 9 minus 12 plus 3, 0. That means fa and fb both are 0. They both are equal, but they are 0. So this is the third condition being met for the Rolle's theorem. This is being met. So the final the step is that the value at certain point which gives the differentiation as 0. So that C should lie between 1 and 3. If it is lying between 1 and 3, then the Rolle theorem is satisfied or is shown. So f dash x has to be 0. So just take this function, take the differentiation and put it as 0. Whatever value that comes is the value which we are interested in, and that has to be between 1 and 3. So when we differentiate it, it will be 2x minus 4. And when we put this as equal to 0, 2x minus 4 equals to 0, that is going to be x equals to 4 by 2. So you get x as 2. Now you just have to see whether 2 lies between 1 and 3, and absolutely in this case 1 and 3, 2 is actually intermediate between 1 and 3. And this is the C value. This is the C value for which the differentiation of this function is going to be 0. And that actually aligns with the theory or the discussion of Rolle's theorem. Now how are you going to write it? This is the whole scenario. These are the steps you are going to write, and this is the way you are going to put this in front of your examiner. The next question is also exactly the same way, and there are questions which are coming which are absolutely like this. So there are certain things which we have to understand. The continuity and differentiability is all okay. Why? Because it is a polynomial function, and we have to find out a value between 1 and 2 that gives you the differentiation of the function as 0 when fa equal to fb. So we will do this question, and all the questions which are coming up after this, most of them are like this. So I'm going to skip them, so just understand this properly. X minus 1 into x minus 2 whole square. X minus 2 whole square is basically the square of x minus 2. So it will be a square plus b square plus 2ab. Not that 2ab that some politician said that we get extra 2ab. No. X square plus 4 minus 4x. So x minus 1 into x square plus 4 minus 4x. You multiply it, and then you get a proper function, and that function will be a polynomial function, which is actually the simplified version of, or the same version of this when we open this x minus 1 and x minus 2 whole square. So finally we land up with a function which is x cube minus 5x square, and this one 8x, and this is negative 4. So this is the actual function which is the same as the previous function. We have just opened it and multiplied everything. So continuity differentiability, no problem, because this is a polynomial function, and the continuity and differentiability is ascertained already in our previous discussion. So we have f1 and f2, that is the endpoint 1 and 2. We are going to find out the value of this function at 1 and 2. When we put or insert 1 in place of x, when we insert 2 in place of x, the first function will give you certain value. The second function, when we put 2, that is 2 cube minus 5 into 2 square plus 8 into 2 minus 4, it's going to give you another number. So when you find out this number, it is going to be 0. This also will be 0. So f1 is actually equal to f2. So that is the third condition of the Rolle theorem is also being ascertained, is also being met. So when you have these three conditions being met, the fourth is simply the differentiation of the function, put it as 0, whatever x comes is your c, and that c should lie between 1 and 2. So this c should be between 1 and 2, and when we take the differentiation of this function, we just put it as 0. So that x, which we find out by putting f dash x equal to 0, is actually the c we are interested in, which will lie between 1 and 2, and we'll check it. So f dash x is differentiation of this. X cube differentiation is 3x square. This is going to be 5 to the 10 minus 10x, and then we have here 8. So plus 8 it will be, 4 will be 0. So this is the differentiation of the function, and we are going to put this as 0. Now we will find out the roots of this. So this is a quadratic equation. You know how to find out the roots. 8 is a 24. 3 and 8 is there. So how are you going to get this 10 out of it? So it is 6 and 4. 3x square minus 6x minus 4x plus 8. 3x you can take common, x minus 2. Minus 4 you can take common, x minus 2. Now you can take x minus 2 common. It will be x minus 2 into 3x minus 4. Now just put it as 0. These two factors will give you x as 2 and x as 4 by 3. Now the point here which I want to highlight is 1 and 2 are the endpoints. We are talking about a value which has to be between 1 and 2. I hope you got the idea. So we cannot take x as 2 here. We have to take the other value, which is x equals to 4 by 3, which is essentially between 1 and 2. That is the whole theory of the Rolle's theorem. So x equals to 4 by 3 is in between. It is between 1 and 2. So this is x is 4 by 3. C is what? It is 4 by 3. And that lies between 1 and 2. And that is the whole idea of the Rolle theorem. It is being ascertained and it is being verified also. Now how we are going to do it? This is all the steps you are going to follow. Write it neatly, cleanly, and show it to the examiner that you know all the steps right from the opening of this function till the finding of the roots, and finally finding out the value 4 by 3, which is lying between 1 and 2, and finally saying that Rolle theorem is verified in this. Okay, this question which we have just discussed. Now the next questions which are coming are actually simpler to this one. So I hope and I encourage you to do it by yourself. So I'll give you a reference. Don't worry, this is the reference for you. So if you're trying it by yourself, then you have to follow all these steps. And I know that you don't need the help of this reference, because if you have understood the previous question, this is just you can say very easy for you. So 1 and 1 by 3 is going to come. As I said, 0 and 1, these are the endpoints. So 1 by 3 will be the C point. Same here, x square minus 1 and x minus 2, you have to multiply. The only thing which comes here in this question which needs to be discussed, when you take the root, it's not going to come in the way we would expect, easy. So we have to use this Sridharacharya formula, and when we apply the Dharacharya formula, you will get 2 minus root 7 by 3 and 2 plus root 7 by 3. Both the values are between negative 1 and 2. So both the values are going to satisfy the condition. As I said, Rolle's just say at least 1, so it can be more than 1. So same thing here, so it's quite easy for you. X minus 4 whole square multiplied by x, so just multiply these two, open this square, multiply, and then take the differentiation equals to 0. The value you will get is 4 and 4 by 3. As I said, you cannot or you should not take 4. 4 by 3 is between 0 and 4. That will suffice this Rolle's theorem scenario. Same question, all these questions are similar. As I just put in the first question my views that all the questions which are coming, if you understand that question, these are all going to be quite easy for you. The same here, x square minus plus 5x plus 6, similar thing. Okay, now this this is a question. Again, the question which are coming are exactly like this. So I would like your attention to understand this question. So this is cos 2 into x minus pi by 4. And this has to be checked between 0 and pi by 2. So this is cos 2x. I'm multiplying 2 inside. It will be cos 2x minus 2 into pi by 4 is pi by 2. I can write it as cos minus. I'm taking minus outside. So from the bracket, it will be cos negative pi by 2 minus 2x. But cos minus theta is plus cos theta. If you remember, sine negative theta is negative sine theta. But in case of cos theta, cos negative theta is not negative cos theta. In fact, it is cos theta. So just you can just ignore this negative sign in between. So you are left only with cos pi by 2 minus 2x. So cos 90 minus theta is what? It is sine theta. Cos 90 minus theta is sine theta. So you can write this 90 minus theta, because negative I already told you it is going to give you anyways positive. So cos 90 minus theta is going to be sine theta. So just write sine 2x. So I hope you got the idea that cos 2 into x minus pi by 4 is nothing but sine 2x. So we are going to deal with sine 2x, and you will be surprised to know the next question is exactly on sine 2x, which is essentially the same as this question. So we have to check it's between 0 and pi by 2. So this is 2x, and as I said, because this is a sine angle and it is continuous also, it is differentiable also, those two conditions are being met. So you don't have to prove it or just mention it or just write it, that because it is a sine function, the continuity differentiability is ascertained. Then the endpoint 0 and pi by 2, put the value as 0 in x and pi by 2, and you will get sine 2 into pi by 2, that is sine pi. Sine pi is 0, if you put 0, sine 2 into 0 is sine 0 is 0. So both the values at 0 and pi by 2 is going to give you 0. f0 and f pi, both are 0. Next one is the differentiation. So you have to differentiate this sine 2x and just put it as 0. This is fx. So we are going to differentiate this fx, that is f dash x, which is going to give you sine 2x as cos 2x, and differentiation of 2x is 2. So 2 cos 2x you will get, and just put it as 0. So f dash x equals to 0. So this x is nothing but c, which we are talking about. So when you put it as 0, cos 2x is 0. When 2x is 0, what should be 2x? Okay, see, 2 into pi by 4, if I write, it is going to be pi by 2, and cos 90 is 0. Cos 0 is 1 and cos 90 is 0. So this you have to have x as pi by 4 in order to get the 0. So finally x is pi by 4. Now you have to check whether this pi by 4 is actually lying between 0 and pi by 2. Yes, because 0 is 0, pi by 2 is 90 degree, and pi by 4 is 45 degree. That means we have C as pi by 4, and that belongs to 0 and pi by 2. So all the conditions of the Rolle's theorem are satisfied, and we have found out the value of C also, which is pi by 4 in this case. This is the solution. This is the reference for you. How you are going to write it, how are you going to present it. I always tell the logic, writing and presenting is what I show, because that is not the idea. If you understand the logic, you will be able to write in the proper way. So now we have just seen a question, and I indicated that sine 2x is going to come, and this is the sine 2x. So I hope this is quite easy for you now. If you understand the previous one, same thing you have to apply, same logic, same discussion. Again, cos 2x, it has to be checked between negative pi by 4 and pi by 4. Again, I'm pretty sure, confident that you are able to understand and do this question by yourself. Just see, this is a reference for you. If you are stuck anywhere, you can just refer this solution. E to the power x sine x 0 to pi. So with sine x we have e to the power x. So we are going to do this, and the criteria, the process will be unchanged. So e to the power x sin x. Next question is e to the power x cos x, by the way. So you have to understand this e to the power x sin x, which I am going to explain you just now, and this e to the power x cos x will follow. So e to the power x sin x, if you understand, other questions will be easier for you. So the range, or no the range, it is domain. So domain is 0 to pi. The function is e to the power x sin x, e raised x sin x. E raised x is continuous differentiable. Sin x is continuous differentiable. When both are continuous, both are differentiable. If a and b both are continuous differentiable, a into b, these function of type are also the same. That is, they are also continuous and differentiable. So you don't have to worry about the first two conditions. They are already met in this particular scenario. But you have to write it. The next one is a is 0. B is pi. So we will find out fa and fb. So in place of a, put 0. In place of b, replace it by pi. And then we have e raised 0 sin 0, e raised pi sin pi. Sin 0 is 0 only. So you know that the value of f0 is 0 in this case. And e to the power pi sin pi, again the value will be 0. Both cases f0 and f pi, the value will be 0. So continuity differentiability is established. Fa equals to fb is also established. Now the final thing for us to show is the differentiation of this function should give you a value at 0 equal to 0, and that particular value which will give this differentiation as 0 is the value which should lie between 0 and pi. So e to the power x sin x, I am going to differentiate it. Ex sin x, I am applying the product rule. So e raised x cos x plus sin x, e to the power x will be the same. Now take e raised x as outside, sin x plus cos x it will be. Now put it at 0. Put it at 0. So e has a proper numerical value. So you can just Go with sin x plus cos x. Just put sin x plus cos x as 0. Sin x will be equal to negative cos x. Divide both sides by sin x. You will get 10x as negative 1. Now 10x minus 1 is what? 10x is 1 when it is pi by 4. When 10 is 45 degree, tan 45 degree is 1. Whenever you have negative value, just subtract it by pi. That is the trick. So pi minus pi by 4 is 3 pi by 4. And the point is that this 3 pi by 4 is actually lying between 0 and pi. If you want to find out the degree of this, you always multiply this by 180 by pi to get the value. And this is between 0 and pi. To find out that 0 is 0, pi is 180 degree, and this 3 pi by 4 is actually coming in between 0 and 180 degree. So we have 3 pi by 4 as the value which satisfied this Rolle's theorem, and we have verified it as well. So this whole e to the power x sin x, because as I said, next question is e raise x cos x. It has to be done exactly the same way I just told you. These are the steps you have to follow, all in English or writing you have to do. Same way here in this question also. Only the domain has changed. It is negative pi by 2 to pi by 2. Others are absolutely same. So C is pi by 4 in this case. It is going to come as pi by 4. And this is the steps which you may follow if you are attempting this question by yourself. Again, cos 2x, this one, sin x by e to the power x. Now this we are going to take in the next discussion. Till then, thank you so much and take care of it.